Hello and welcome to another episode where we are going to use the statistical software package SPSS to demonstrate how we can calculate some correlation coefficients. This is part of our introduction to statistics. So first of all, we need SPSS, which I have open over here. Now I'm going to use a more practical data set that I got from this statistics book, Statistics and Data Analysis for Nursing Research. What they've done is they have done a survey and gathered a lot of information from a certain group of like 1,000 women in a certain community. And they made this, they put this in SPSS and they made these data files available through their website. So that is what we're going to use. There are three different data files to make it accessible for any version of SPSS. The first one we're going to use is the B set. So I'll just show you here. There are three different sets, an A, B, and a C, and we are opening the B one. All right, so let's get started. We're going to create a correlation matrix with 4 variables from this data set. The 4 variables that we're going to use is the doc visit, the number of visits to a doctor in the past 12 months, the body mass index, which is over here, and then the short form health survey for physical health, which is way down here, this one, as well as the mental health survey that was collected by the authors. So how do we do that? Well, first, we're going to click on Analyze here at the top. Let me just move this a little bit down so you can see, maybe like that. There we go. Analyze at the top. Then we're going to go down to Correlate. Then Bivariate. And we get a small window here that we can resize to see the variables. I can't make these words bigger right now, unfortunately, but we are looking for those 3 variables that we mentioned. Number of visits to the doctor, that's doc visit over here. We're going to click on this arrow to move it in to the variables window. Then we're looking for BMI, body mass index is over there. We're going to move that in. And at the bottom 2, the physical health component score, as well as the mental health component score. So there are the 4 variables that we're going to use. Make sure you have Pearson checked here as our correlation coefficient. Then we're going to click on Options. And we're going to check the means and standard deviation. And make sure that the first one here is selected as well. Exclude cases pairwise. We'll continue that. We'll click on OK here. And then it's going to give me the correlation matrix as well as some basic statistics in the output window. Now, this is a little small, but I can click on this and then click on the print preview. And that gives me the option to zoom in, which I'll do occasionally if we want to focus on something and look at these. So now we can answer some questions. Like on the short form 12 subscales, we can check if the women in the sample on average were about as healthy both physically and mentally as people nationally. Now, these 2 surveys sort of have known averages over the whole population as 50 in both cases. So we see here, and again, I'm going to zoom in on this by going to the print preview. We see here that the physical health score for the women in this community, in this sample, has an average of 45. So that is lower than the average by about a half a standard deviation. The average for the population is known for these to be 50. And for the mental health, it is lower. That's what this sample suggests. Not quite as much, a little less than half, more like a third of a standard deviation step below the population mean. Now we can investigate, well, what is likely to be connected to these lower scores that could potentially affect them, but at least have a correlation. So we look at the correlation matrix over here. Let me go to print preview so we can see it a little bit bigger. There we go. That's much better. And we see here there's a lot of symmetry here. It's comparing all the variables with all the other variables. So for example, the number of doctor visits is compared with each of the other variables. And then when for example, body mass index over here, it gives me a correlation coefficient of 0.131. And then if later on I look at body mass index correlated with number of doctor visits, that's of course going to be 131 again. So I have this symmetry, and I only really need to look at half of this table across the diagonal. So they're not all new information. They are sort of copied on either side of the diagonal. And you'll see here in the diagonal, we have a 1 because the variable is, of course, perfectly correlated with itself. So when we look for what is the strongest correlation, for example, in this correlation matrix, we see here that the strongest correlation is this 0.316 between the physical health score and the number of doctor visits. So that suggests that women with higher, more favorable scores in the physical health component subscale on this survey tended to have fewer doctor visits than those with lower scores. We can look here and see what is the weakest correlation in this correlation matrix. The weakest one seems to be over here, the negative 0.078 between the mental health score and the body mass index. So it's an almost negligible correlation between these two variables, which we might suspect, and it might make sense. But again, this is just from our sample. We can look and ask, for example, which variable included here is the most strongly correlated with a specific variable like body mass index. Now I can look at the body mass index in the column or the row. Let's look at the row, for example. And the strongest correlation with body mass index is the physical health component score with a correlation of 0.134. So we can use SPSS to calculate more than just one correlation coefficient. By giving it a number of variables, it will calculate all the correlation coefficients as well as the statistical significance for all the pairs within the variable set that I give it. Alrighty. So that's a nice introduction to how we'll calculate correlation coefficients in SPSS.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
So we can do a little bit more just to reinforce this. But for this next example, let's go and open set A of my 3 dataset files. I'm just going to move this down a touch so we can see the menu options at the top. So we're going to use dataset A from that textbook that I mentioned. And we want to examine the relationship between work week and income. So let's find those variables: work week, hours worked. We can also make this a little bigger here, right? Hours work. I can't speak today. Hours worked per week in the current job that they have. And I want to compare that to their income. Income variable is over here, their family income in the prior month. And again, we're going to do that with the top menu of analyze. Well, we can, yes, analyze, correlate. Sometimes there's multiple ways to do it, but we'll do the same thing as before. Analyze, correlate, bivariate. Oh, it's nice and big for me already. And then we will bring in those variables. What did we say? Work week. Work week is over here. Bring that in. And income. Income. Where are you? There we go. Income. So in this case, I just have 2 variables that I want to test. I do have Pearson checked here at the bottom. My other options should be the same. Where is my output window now? There it is. Let's make it a little bit bigger. Zoom in. And we see there is a correlation coefficient of 0.3 between these variables. Of course, again, the symmetry. There's no order in this correlation coefficient, just 2 variables being correlated. So 0.3 is the correlation coefficient, and it is statistically significant as well. So we can also examine the scatter plot for these data points between these 2 variables. We can do that by clicking at the top menu on Graphs, then the bottom Legacy Dialogues. Then we're going to go to Scatter or Dot. And I'm going to select the simple scatter, the first option, and then we'll define. That brings up a new window that'll just make bigger again a little bit. And I want work week. Where is work week? Hours worked. I'm going to put that on the x-axis. And income. Where were you? Lower down. Income on the y-axis. You could flip them as well. Doesn't really matter. And then we will have everything pretty much ready. Let's click on OK. It's going to plot. I don't need to make that bigger. That looks pretty good already. It's going to plot all the data points. And then I can visually investigate things like outliers. Does this suggest a correlation? What kind of correlation? Now, for realistic data, it is difficult to see where is this correlation. What roughly, if I have to summarize this with a straight line, a topic that's coming up in regression later, what is the trend that connects these 2? And it is, in general, quite difficult to see. They're not all going to sit on a nice line. But knowing the correlation coefficient that I would have to calculate separately to be more sure of my findings, visually I can perhaps see that 0.3. There's maybe a line here that is connecting, that is hinting at the correlation, but it's not super steep. And it's certainly, there's a lot of fluctuation around this line, I can imagine, that connects these two variables. Not sure which one causes which one. We're just investigating correlation for now. So I can't rely on my visual assessment, but it is something that I would like to do and just think, how does my visual assessment in the data set compare with the calculated correlation coefficient? So there doesn't seem to be any restriction in the data values. I get very high income all the way to zero income, as well as low hours worked in a week, as well as very high hours. So it does seem like extreme values or outliers are included here, and in general that's a very difficult thing to identify. You can say, well, this is an outlier over here because it is much higher in terms of income than anyone else with that same amount of work week hours. But then what about these guys over here? Should we still consider those to be outliers? These ones over here on the right, you could argue, yes, it's very moderate income for an extremely large hours being worked in a week. But in general, identifying outliers and deciding where that cutoff line is a very difficult problem, and there is some subjectivity to it. So there may be a few outliers. There's some extreme ones as well. Now, it could be because of anomalous results during the survey process that one might have to double check your results. Someone could say that they worked a certain number of hours, but at the same time didn't get any income. That could be due to the questions and how the questions are phrased, and all kinds of things could affect how the individuals interpret the questions and then answer it. In this case, for example, the income variable is referring to the previous month, whereas the hours worked per week is referring to the current job. So there could be a discrepancy there as someone is transitioning from one job to another, or in or out of a job, could affect these data points. And so that's very important to be aware of. When you're looking at your data set, it can clarify, well, wait a minute, there's zero income, yet people are working. We can then review the exact phrasing of the survey questions and what the variables are trying to reference to refine our survey and improve on it to get, when I calculate the correlation coefficient, to get something that is actually representative of what I'm trying to investigate. So looking at a scatter plot and doing some preliminary or informal visual assessment can really help a lot to make sure that we are calculating something that is representative of what we're trying to calculate. Not to blindly look at a correlation coefficient and just not think of it out of context, or not incorporate what is actually being asked, what is the potential realistic situation affecting the answers of these people. So very important to sort of have a bigger picture and not blindly look at a calculated number and make all decisions on that, because it is very much dependent on the individuals and their interpretation in the process of me collecting this data. Alrighty, that should hopefully give us a decent introduction to using SPSS when it comes to correlation and thinking about correlation and calculating a correlation coefficient. As always, let me know if you have any thoughts, comments, or questions, and we will continue our introduction discussion on statistics in the next video. Until then.